Good evening and welcome to TL Physics, and today I'm going to talk about the relationship between intensity of radiation and the distance the Geiger-Müller tube or any detector is away from the source. Now, this is a very important relationship and it does come up as a required practical. And what I've got to do here is I'm going to basically draw a sketch graph to explain what's happening here. So I've got intensity I in my y-axis. And intensity can be measured in all sorts of things. So intensity can be measured as the amount of activity. It could be, of course, amount of energy released, etc. So the intensity is how much power, energy, becquerels, etc. is from the radiation source. So it could be number of counts that you see on a Geiger-Müller tube, etc. And x here is the distance that you are away from the source. If I was to get a radioactive source and get a Geiger-Müller tube and plot it, put it at 10 centimeters, then 20, then 30, then 40, and look at the amount of counts of radiation I get, I would get a curve that looked like this. Now, this here, okay, is definitely not a linear graph. It's not a y equals mx plus c graph. This graph here is an inverse square. This is a 1 over x squared graph, okay? And what this shows us here is a relationship between the formula that's on the data sheet. Now, on the data sheet, it does say that intensity is k, a constant, divided by x squared. And what it's saying here is that you've got this constant here which you don't know about, and what this constant is doing is affecting the shape of the graph, but the relationship between this and this is an inverse square law. So this is known as an inverse square law. Okay, and the kinds of questions you could be asked in this, of course, is to explain what would happen to the intensity of the radiation if you changed the amount of distance. So let's do an example question here and grab a calculator to be able to do this, and I'll show you how to do this. So let's say at 1.5 meters, my number of counts that I had was, so the number of becquerels, so my counts or my activity was, let's say, 400 becquerels. And the question is, what is it at 6 meters? Okay. And there are two ways to approach this type of question. And you can use this kind of theory for like Coulomb's law or any other inverse square law. The first approach is to look at the relationship between the distance you are and the new distance that you've got here. Now, as you can see, this distance is 4 times bigger. This means if I put this in here, because it's 4 times squared, this means my intensity will be 16 times smaller. Okay, so the first way you could look at that is that 6 meters is 4 times greater, which means the intensity will be 16 times smaller. Okay, and that means the intensity will be 400 divided by 16, which is 25 becquerels. Okay, BQ there. I'm going to do another method now, method 2, and I'm actually going to use this formula here to find the constant. So this is a constant for this situation, so it is going to be the same at the beginning and at the end. So I'm going to do that now. So I know that 400 equals k over 1.5 squared. So k equals 400 times by 1.5 squared. So just going to put that into my calculator, times 1.5 squared, and that equals 900. I'm now going to use my formula. I'm going to have something equals 900 divided by 6 squared, and I get 25. Exactly what you would expect. Now, this method is really useful when you have numbers that aren't nicely increasing by double or triple. They're increasing by a factor of 2.7 or something like that. So it's much nicer to be able to do something like this. This method is perfectly valuable if you have a multiple, etc., to do that. And that's really useful for things like Coulomb's law. But that is the relationship between intensity and the distance away from the source of radiation.